Think about this for a second. While you're watching this video, your computer could be sending small bits of information to Microsoft without you even noticing. It doesn't only happen once in a while. Every time you open a program, click a button, or your computer crashes, certain system data may be sent automatically. Microsoft calls this diagnostic data, but many people see it as something much more serious. For years, people have argued online about whether Windows collects too much information. Some believe it's simply helping improve the operating system, while others worry it's an invasion of privacy. But as big as that debate is, an even larger problem is quietly getting closer. A new wave of technology called quantum computing could completely change how digital security works. It has the potential to break many of the encryption methods that protect your passwords, bank accounts, private messages, and personal files today. And surprisingly, one operating system is moving faster than most others to prepare for that future. That operating system is Linux. In this video, we'll look at what Windows actually collects, what experts have discovered after years of research, why quantum computing is becoming a real concern, and why many security professionals believe open source software could play a major role in protecting our digital lives over the next decade. Let's begin with a topic that has caused debate for years: Windows telemetry. If you've ever opened Task Manager and noticed background processes using your internet connection, you may have wondered what your computer was sending. That's a reasonable question. Microsoft has publicly confirmed that Windows collects diagnostic information from users around the world. This can include details about your device, hardware, drivers, software versions, system errors, and update status. The company says this information helps identify bugs, improve performance, and fix security issues more quickly. When Windows 10 launched in 2015, these data collection practices immediately raised privacy concerns. Many users felt they weren't fully informed about what was being collected or why. Privacy groups and government agencies also started asking tough questions, leading to investigations in several countries. The discussion wasn't simply about technology. It became a larger conversation about how much control people should have over their own computers. As concerns about privacy continued to grow, government regulators began taking a closer look at Microsoft's data collection practices. In 2017, the Dutch Data Protection Authority concluded that many Windows 10 users were not given clear enough information about the diagnostic data being collected. Around the same time, France's privacy regulator, known as CNIL, also questioned Microsoft's handling of certain user data connected to advertising features. These weren't just complaints from online forums. They were official investigations by government agencies responsible for protecting consumer privacy. In response, Microsoft made several changes. The company updated its privacy settings, explained its data collection in more detail, and introduced new tools designed to give users better visibility into what Windows was doing behind the scenes. One of those tools was the Diagnostic Data Viewer, released in 2018. The idea sounded simple: allow users to see the information their computer was sending to Microsoft. But once people opened the tool, many quickly realized it wasn't easy to understand. Instead of plain English, users were greeted with long lists of technical events, system codes, timestamps, and detailed logs. For IT professionals, the information could be useful. For the average Windows user, however, it often felt confusing and difficult to interpret. Microsoft deserves credit for offering more transparency, but many people still felt they couldn't easily understand exactly what their computers were sharing. The level of control also depends on which version of Windows you're using. Large businesses, schools, and government organizations have access to advanced management tools that allow administrators to control and monitor much of the diagnostic data being collected. Home users don't have the same flexibility. If you're using Windows Home or Windows Pro, you can reduce some optional diagnostic data through the Settings menu. However, Microsoft does not provide an official way to completely disable the required diagnostic data that Windows needs for its core services. Because of this limitation, many users turn to third-party privacy tools that promise to block additional telemetry. While some of these programs can reduce certain background activity, Microsoft doesn't officially recommend using them, and changing important system settings can sometimes create unexpected problems. Windows 11 has also introduced newer diagnostic features focused on improving performance. For example, if your computer starts running slowly, Windows may create a local performance log. According to Microsoft, this information stays on your computer unless you choose to send it through the feedback hub. That sounds like a more privacy-friendly approach, but it also raises another question. What exactly counts as slow performance? Microsoft hasn't publicly explained every condition that triggers these logs. Without that level of detail, some users remain unsure about how often these performance records are created and what information they include. This uncertainty is one of the biggest reasons the privacy debate continues today. It's not always about believing Windows is secretly spying on users. For many people, it's simply about wanting more control and clearer answers about what their own computers are doing. Now here's where the story becomes much more interesting. After years of online claims and heated debates, one important question remained. Is Microsoft actually reading your personal files, emails, photos, and private messages through Windows telemetry? Technology journalist Ed Bott spent more than 10 years researching that exact question. Instead of relying on rumors or social media posts, he examined Microsoft's technical documents, monitored network activity, and spoke directly with company engineers and executives. His conclusion was clear. He found no reliable evidence that Windows telemetry is secretly collecting the contents of your personal documents, emails, photos, or private conversations. According to Microsoft's own documentation, the required diagnostic data mainly includes technical information such as device details, hardware IDs, driver versions, systems, performance, update status, and crash reports. The goal is to help engineers find bugs, improve compatibility, and fix problems across millions of different computers. Microsoft has also stated that required diagnostic data is not used to collect things like your browsing history, typed text, voice recordings, or personal files for advertising purposes. That doesn't mean everyone is satisfied. The biggest concern isn't necessarily what is being collected. It's the fact that users can't completely turn off the required diagnostic data on standard consumer versions of Windows. You can lower the amount of optional data that's shared, but some information continues to be sent because Windows depends on it to operate and receive updates. There's also another feature called tailored experiences. When enabled, Windows can use certain optional diagnostic information to personalize recommendations, tips, and some advertising-related content. Fortunately, users can disable this feature, but many privacy advocates believe it should have been turned off by default instead. This highlights the trade-off that exists in modern technology. Microsoft argues that collecting diagnostic information helps improve Windows for over 1 billion active devices around the world. With countless combinations of processors, graphics cards, drivers, and software, it's impossible for engineers to manually test every situation. Diagnostic data acts like a giant feedback system. When enough computers report the same problem, Microsoft can identify the issue faster and release a fix that benefits everyone. From an engineering standpoint, that makes sense. But from a privacy standpoint, many users still feel they should have complete control over what leaves their computers. That's why opinions remain divided. Some people see telemetry as a useful tool for improving software. Others see it as unnecessary data collection that limits user choice. The truth probably lies somewhere in the middle. Windows telemetry is not supported by public evidence as a secret system designed to steal your personal files. At the same time, it also isn't something most home users can fully disable using official settings. And that's exactly why more privacy-focused users have started looking at alternatives, not because they believe every conspiracy theory they read online, but because they want an operating system that gives them greater control over what happens behind the scenes. And that's where the conversation shifts away from telemetry and towards something that could have a much bigger impact on everyone's digital future, quantum computing. While people continue debating Windows privacy settings, a much bigger challenge is slowly approaching, one that could affect almost everyone who uses the internet. It's called quantum computing. Right now, the security of online banking, shopping, email, messaging apps, medical records, and countless other services depends on encryption. Encryption is what keeps your information private by turning it into unreadable code that regular computers can't easily break. Today's encryption is based on mathematical problems that would take even the fastest traditional supercomputers an incredibly long time to solve. In many cases, we're talking about thousands or even millions of years. That's why we trust it. But quantum computers work in a completely different way. Instead of solving problems like normal computers, they can process certain calculations much more efficiently. If scientists build powerful enough quantum computers, they could eventually break many of the encryption methods used across the internet today. Researchers have known about this possibility for years because of a mathematical method called Shor's algorithm. In theory, a large enough quantum computer could solve problems that current encryption depends on, not over centuries, but potentially in hours or days. The important thing to remember is that this isn't just science fiction anymore. Governments, universities, and major technology companies are investing billions of dollars into quantum research. Although today's quantum computers are not yet powerful enough to break modern encryption on a large scale, many experts believe it's only a matter of time before the technology reaches that point. And here's the part that often surprises people. Hackers don't need a powerful quantum computer today to create a problem for the future. Security experts have a name for this strategy: harvest now, decrypt later. The idea is simple. Someone can collect encrypted information today, even if they can't read it yet, and store it for years. That data might include emails, financial records, business documents, medical information, or private conversations. Once quantum computers become powerful enough that stored information could be decrypted using future technology. In other words, data that's considered secure today may not stay secure forever. That's why governments and cybersecurity experts aren't waiting for quantum computers to arrive before taking action. Instead, they're already developing a new generation of encryption called post-quantum cryptography, often shortened to PQC. These new algorithms are designed to resist attacks from both traditional computers and future quantum computers. In August 2024, the U.S. National Institute of Standards and Technology, NIST, officially announced the first group of standardized post-quantum encryption algorithms. This marked a major milestone because it gave governments, businesses, and software developers a common set of security tools for the future. The race isn't about replacing the internet overnight. It's about upgrading today's digital infrastructure before quantum computers become powerful enough to threaten it. And this is where Linux begins to stand out in a very important way. As the technology world prepares for the quantum era, Linux has become one of the biggest driving forces behind the move to stronger security. Unlike closed operating systems, Linux is open source. That means anyone can inspect the code, suggest improvements, find bugs, and help strengthen security. Instead of relying on one company's internal team, thousands of developers, researchers, and security experts from around the world work together to improve it. In 2024, the Linux Foundation launched the Post-Quantum Cryptography Alliance, bringing together technology companies, universities, and cybersecurity experts to develop encryption that can resist future quantum attacks. One of the most important projects is Open Quantum Safe, OQS, an open source effort that helps developers test and deploy quantum-resistant encryption across different operating systems. While these tools can also be used on Windows and Mac OS, much of the early development has happened within the Linux ecosystem. And this isn't just experimental research anymore. Major Linux distributions like Red Hat Enterprise Linux have already started adding support for post-quantum encryption to secure web traffic and remote connections. Software used across the internet, including OpenSSL, is also introducing support for these new security standards. Even companies that manage large portions of internet traffic, such as Akamai, along with web technologies like Nginx, are preparing for the transition. The goal is simple: upgrade today's internet before tomorrow's computers can break today's encryption. This highlights one of Linux's biggest strengths. Because the code is public, security improvements can be reviewed by experts around the world. Problems can be found more quickly, updates can be shared faster, and anyone with the right knowledge can verify how the system works instead of simply trusting a company's claims. That doesn't automatically make Linux perfect, and it doesn't mean Windows is insecure. Microsoft continues investing heavily in cybersecurity and is also working toward post-quantum protection. The difference is that Linux allows the global security community to participate openly throughout the development process. As quantum computing continues to advance, transparency and speed may become just as important as the technology itself. So what does all of this mean for you? First, don't panic. There's no strong public evidence showing that Windows telemetry is secretly reading your personal files or private conversations. Much of the information collected is intended to improve system reliability and security. At the same time, many users still want greater control over what their computers share, and that's a fair discussion to have. But the much larger issue isn't telemetry. The bigger challenge is making sure the encryption protecting your passwords, financial information, personal files, and online accounts remains secure in the years ahead. That's why governments, researchers, and technology companies are already preparing for a future powered by quantum computing. Whether you use Windows, Linux, or another operating system, the most important thing is staying informed and keeping your software updated as these new security standards become available. The future of online privacy won't depend on one operating system alone. It will depend on how quickly the entire technology industry adopts stronger encryption before quantum computing changes the rules. If you enjoyed this breakdown and want more easy-to-understand videos about technology, cybersecurity, and digital privacy, don't forget to like this video and subscribe to the channel. Thanks for watching, and I'll see you in the next one.